Hello students, this is your teacher Sir Naushad Mehdi, and in today's video we'll be going to discuss the numericals which are related to the topic of the moles and stoichiometry, and these numericals are taken from your past paper questions. Now before directly solving the numerical, first of all let us have a quick recap about the formulas which is going to be used in this numerical. The first one is a very basic formula which is of the moles. If you want to calculate the moles of any substance, so what you have to do, you have to divide the mass, whatever the mass is given in the question, with the AR or MR. And similarly, the second formula is for calculating the volume of a gas at RTP, room temperature and pressure. So we have already studied that 1 mole of any gas occupies a volume of 24 decimeter cube at room temperature and pressure. Alright, so for 1 mole you have a volume of 24 decimeter cube. So whatever the moles are given in the question, for example 2 moles or 3 moles, so whatever the moles are given, you just have to multiply those moles of the gas with 24 in order to get the total volume of the gas, which would be at RTP, room temperature and pressure. Now let's start our numerical. Now in the first question it is saying that fluorine reacts with the sodium hydroxide to produce sodium chloride, water and oxygen, and the equation is given to you. Now in this question what they are saying, calculate the maximum volume of oxygen produced in DNQ. So what they are asking you to calculate the volume of oxygen. So in the equation find out where is oxygen, so in the product you will find it out. And they are asking you to calculate the volume of this oxygen gas, and they are asking you to calculate at room temperature and pressure. It means that they are asking you to calculate the volume at RTP for this oxygen gas. Alright, so this is the unknown. Then 0.037 moles of sodium hydroxide. Now the moles are given, and the moles for sodium hydroxide is given to you. Now in the equation, where is sodium hydroxide? This is sodium hydroxide NaOH, and for this the moles are given to you, and the moles is 0.037 moles. React completely with the fluorine. Now NaOH moles are given to you, and they are asking you to calculate the volume of oxygen gas at RTP. Now if I ask you, if you want to calculate the volume of oxygen gas, right, so if I apply the formula volume of oxygen gas at RTP, so what would be the formula? Formula is written already over there, that you have to use the formula moles. Now over here what moles I have to use? I have to use the moles of oxygen gas. Whatever the volume of the gas is required, so you have to use the moles for that particular gas. So over here they are asking you to calculate the volume of oxygen gas, so you have to use the moles of oxygen gas and multiply those moles by 24 decimeter cube. So you have to use this formula. Now in order to use this formula you need the moles of oxygen gas, which is not given in the question, right? In the question you can see the moles of oxygen gas are not given to you. You are being provided with the moles of NaOH, which is 0.037. So you cannot use those moles in this formula, right? So for that what I have to do, first of all I have to determine the moles of oxygen gas first. And if I want to determine the moles of oxygen gas, so what I will do, I will apply the ratio in between the NaOH and oxygen gas. So according to the balance equation, NaOH is having 4 moles and oxygen, before oxygen nothing is written, it means it's 1 mole. So according to the balance equation the ratio is 4:1. So I will write 4 moles ratio 1 mole. So this is the ratio which is according to the balance equation. Now I will apply that number of moles in the ratio which is given in the question as a data. So as in the form of data, the moles of the NaOH which is given is 0.037. So I will put over here 0.037 moles which is given in the question. So if 0.03 moles of NaOH will react, So how many moles of oxygen gas will be produced? That would be X moles, right? So according to the balance equation, if you are having 4 moles of NaOH, so only 1 mole of O2 will be produced. So right now we have 0.037 moles of NaOH, so X moles of O2 will be produced, and if you want to determine the value of X, so you have to cross multiply it, and when you will cross multiply it, so you will get X equals to 0.037 divided by 4. And in the calculator, if you divide 0.037 by 4, so you will get the answer 0.00925. These are the moles of oxygen gas, O2. Now since you have determined the moles of oxygen gas, so now what I will do, I will put these moles in this formula of volume in order to get, right? Since the moles are already known now, so I will apply this formula, volume of oxygen gas at RTP. That is moles multiplied by 24. So moles of oxygen you have calculated just right now, which is 0.00925 multiplied by 24. So when you will multiply by 24, so you will be getting 0.222, and they are asking you to give the answer in 2 significant figures, right? So in the calculator it is showing 0.222. So since we want the answer in 2 significant figures, so we will write 0.22. These are the 2 significant figures, and the answer would be in decimeter cube. So this is your final answer for this question. I hope that is clear to everyone. Okay, now let us solve one more question. Now in this question it is saying calculate the minimum mass of sodium in grams. So they are asking you to calculate the mass of sodium needed to produce 300 centimeter cube of hydrogen gas at room temperature and pressure. So in the question 300 centimeter cube, 300 centimeter cube means volume it is given to you, right? Centimeter cube is the unit of the volume. So volume of hydrogen gas is given to you at RTP, room temperature and pressure, and that is 300 centimeter cube. Now since the volume is given in centimeter cube, so I have to convert this volume into decimeter cube first, and you must know the conversion that 1 decimeter cube equals to 1000 centimeter cube. So if I divide 300 by 1000, because you want to convert centimeter cube into decimeter cube, so if you divide 300 by 1000, so you'll be getting the volume which is 0.3 decimeter cube. So 0.3 decimeter cube is the volume of hydrogen gas at RTP which is given in the question. And they are asking you to calculate the mass of sodium. Now, since we know that we have to use the formula, since the volume is given to you, so it means it is giving you a hint that you have to first of all use the volume of a gas formula first. So when we will start solving it, so first of all I will apply the formula for volume of gas at RTP, and that formula is moles multiplied by 24 dm cube. Why I am using this formula first? Because the volume is given in the question, which is 0.3 decimeter cube. So I will put 0.3 decimeter cube volume over here, volume of the gas at RTP, equals to moles. I do not have the moles of the hydrogen gas, right? So I want to know the moles of hydrogen gas. What is the mole of hydrogen gas? Multiply by 24 decimeter cube. So 24 will go on that side, and this will give you the answer for the moles of hydrogen gas. So it would be 0.3 divided by 24. So when you will divide 0.3 by 24, so you'll be getting 0.0125 mole. So these are the moles of the hydrogen gas. Now what I will do, since I want to know the mass of sodium, so what I will do, I will apply the ratio again, and I will apply the ratio in between the sodium and hydrogen. Now according to the balance equation, the sodium moles are 2 in the balance equation, and before hydrogen nothing is written, it means that it is having 1 mole. So according to the balance equation, the moles of the sodium are 2 moles, and for hydrogen we have 1 mole. Now since we have already determined the moles of hydrogen gas, these are the moles of hydrogen gas, 0.0125. So below hydrogen I will write 0.0125 moles, and if 0.0125 moles of hydrogen gas are given to you, then what moles of Na would be required? That would be X moles. So if you will cross multiply it, right, so you will be getting the answer X equals to 0.0125 multiplied by 2, and when you will multiply by 2, so you will be getting 0.025. and what is 0.025? That is the moles of sodium. That is the value of the X, and the value of the X is denoting the moles of sodium, and the moles of sodium you would be getting 0.025 moles. Now after determining the moles, still my question is not finished, because they were asking you to calculate the mass of sodium. Now since I know the moles of sodium, so I can easily convert this moles into mass by applying the formula of the moles, and I know the basic formula of the moles, that is moles equals to mass in gram divided by AR or MR. So in case of sodium, sodium is an atom, so atom, in case of atom you will be taking AR, right? So moles you have already calculated 0.025, and you want to convert these moles into mass. So mass upon AR. AR you have to look at from the periodic table, and the sodium's AR is 23. So you will cross multiply it, and when you will cross multiply it, it will get you the answer for mass of sodium. So mass of sodium would be 23 multiplied by 0.025, and when you will multiply by 23, you would be getting 0.575, and you have to give the answer in 3 significant figures. So you are already getting your answer in 3 significant figures. Mass of sodium equals to 0.575 grams. So this is the final answer, and this answer is already in 3 significant figures. So I hope that this question is clear to everyone, and you get a better idea how to apply the formulas in this stoichiometric problems according to the data which is given in the question. So thank you for watching this video, and meet you in the next video with further more questions from the past papers. So take care, and Allah Hafiz.